Incidentally, on that control panel, that orange little rectangle with the white arrow is a toggle switch. It minimizes and maximizes.
Okay.
So if it's taking up space on your desktop, you can minimize it.
Okay. Did you receive the email I just sent? I don't know if it's any better, but
we'll have a look here. Usually takes a minute or two. So while we're waiting, I'm kind of hearing echo. Are you hearing that echo? Oh, no.
A little bit.
Only occasionally, yeah. It's not always there. In fact, it's gone now. So the first problem, what does the first problem say?
It says the directions are find a quadratic function in any form for each parabola described.
Okay.
And then number 1, it gives you the vertex, which is -1, 5. And 1 x-intercept, which is 14.
Okay. So it looks like, have you done some of these already?
Yeah.
Okay.
I did number 2 and I got that, but I didn't do number 1 yet.
Okay. Well, let's look at 1. So
okay.
Probably when you have a vertex, the vertex format is the best way to do it. So what's the standard general formula for the vertex format?
Y equals A times X minus H plus K.
Quantity squared plus K.
Yeah.
Okay. So H and K are the vertex. So how much do we know about this? We know
H is 1.
So what goes in the parentheses?
Plus 1.
Okay.
And then plus 5.
Okay. All right. And the fact is, at this point, is all we need is one other point on that parabola to solve for A. In other words, if we have one other xy point, and it doesn't really matter if it's the x-intercept or they've just labeled a point, as long as it's something other than the vertex, we'll solve for A and we'll have our equation. So to give us this point, what does that correspond to?
14, 0.
Okay. So let's substitute that point in for x and y.
So then 0 equals A times 14 plus 1 squared plus 5.
Okay. So that's 225, 15 squared, and that's equal to minus 5. What 5 goes in there? 5 times minus 1/25.
Okay.
And so what's our final equation?
Y equals negative 1/25 x plus 1 plus 5, squared plus 5.
Okay. And you've done 2? Here,
Yes, I did 2.
Let me check my inbox. You know, that didn't come. I wonder if it went to my spam. No.
It's sending it because it was a bigger image, so I think
bet
it's just taking a while.
Whatever the problem was, I think you've probably solved it. Because when you have greater resolution, it's a much larger file.
Yep, I did the greater resolution one.
Oh, okay. Well, I'll get it in a second. I'm still kind of surprised that you sent it to David. You sent it to the same email.
Yeah.
David Cowan, 1949. Okay. I can't really read 2, but it looks like 3. You could probably read that to me.
Yeah.
Have you done 3 already?
No, I did 2, so I don't need help on 2. But 3 is maximum value 9, and zeros are -2 and 4.
Okay.
Yeah.
So what format would you like to use here?
I think it's called intercept format.
Well, we could use x-intercept format. What's the general format on that?
Y equals A times x minus P times x minus Q.
And P and Q are?
2 and -4.
Right. In other words, P and Q are the zeros.
Yeah.
Okay. So that becomes x plus 2, x minus 4, and now we have to solve for a again. So this time, what point are we going to put in for x and y?
0, 9.
Well, in this case, since we've started out with the x-intercept format, we actually can use the vertex if we knew both points of the vertex. So do we know both points? We know the maximum value is 9, which means it's a parabola that looks like that. And this point is -2, and this point's 4. So what is the vertex?
Oh, it's 1, 9.
Yeah, very good.
Okay.
So 1, 9. Again, what should I write next?
9 equals A times 1 plus 2 times 1 minus 4.
Okay. What is that? 3 times -3, so -9. So A looks to be -1.
Okay.
And so the equation -1 or just minus. And it's always a good idea to check that, make sure that the sign matches the shape. Since they told us that it was a maximum, we know it's a parabola that opens down, so it should have a -a.
Yeah.
Now, since we had to figure out the vertex anyway, it would have been also just as easy to put this in vertex format. In other words, I like doing x-intercept because we knew the x-intercepts, but we really didn't know another point on the graph. We had to figure it out what the axis of symmetry was. Well, since you got to figure that out anyway to come up with the vertex, vertex format might be a little easier. And then you plug in one of the x-intercepts as your point. So I guess it's about the same degree of difficulty.
Okay.
Half dozen,
Yeah.
0.6 of the other. All right.
It said the email sent, so.
Yeah, I'm surprised I haven't gotten it yet. Huh. Well, let's do as best we can.
Okay.
Until we get it. What does this problem say?
Number 4 says a circular pool with a diameter of 44 feet is surrounded by a deck of uniform width.
Okay.
The area of the deck of the pool is 245 pi feet squared.
So the shaded area is 200 and what? 45 pi?
Yeah, 245 pi feet squared.
Okay.
And then it says determine the width of the deck.
Okay. So shaded area problems are always what kind of problems? They're always subtraction problems.
Always subtraction. Oh, okay.
In other words, we don't know how to figure the area of that deck. But if somebody were to say, what is the area of the deck? It's the area of the outside circle minus the area of the inside circle. Right?
Mm-hmm.
All right. So let's write that. The area of the shaded region is the area of the big circle minus the area of the small circle. Well, they've given us the area. So now it's just plug in. The area of the shaded is 245. The area of the big circle, we don't know. We're solving for that. But what's the area of the small circle?
Pi times diameter.
Area is pi r squared.
Oh, pi. Okay, so 20.
Here's the two most important formulas, and probably in all of math. Notice that the same three numbers are in both. You start with the area, you bring the 2 down in front, and you have the circumference. Now, one way I remember that, it's a stupid little way, but it works, and that is pi are not squared, they are round. So pi r squared has a certain ring to it. I don't know if you even got that, but okay. So it's 22 squared pi. What is 22 squared? Do you have a calculator? Ellen, do I still have you? I seem to have lost audio. Did get the other email. Ellen?
Hello?
Hi, Ellen. I seem to have lost audio with you.
Yeah, I realized that. My computer is having a problem.
So can you put this on speakerphone right now?
Yeah, I can.
Well, let's finish the audio this way. Now,
Okay.
can you see my screen still?
Okay.
Are you able to still see my screen? It looks like you're still logged in with GoToMeeting.
Yeah, I can see your screen.
Okay, I did get the second photo, and it's much better.
Okay.
Okay, so I'm not sure where you lost me. Were you always able to hear me?
I can't, I didn't hear you for a little chunk.
Okay. Well, we've got this equation over here, that the area of the shaded region is the area of the big circle minus the area of the small circle. They gave us the area of the shaded region. We can figure out the area of the small circle. It's pi r squared. R is 22. So what's 22 squared?
Or 484.
484 pi. So solving that equation for the area of the big circle gives you 239 pi, I believe.
How did you get that?
By this equation right there. The one I'm circling.
Yeah.
In other words, I added 484 pi to both sides.
Uh-huh.
And, oops, hold on. I'm sorry. I did my addition wrong. No wonder you said, how did you get that? I got to add that. It's 729 pi, right?
Okay.
All right. So that's the area of the big circle, and the area is equal to pi r squared. So divide both sides by pi, and you got r squared equals 729. Square root of 729 is what?
27.
How much?
27.
Okay, and what's the question? What's the width, huh? So what's the diameter of the large circle?
54.
So what's the width of the deck?
It is, oh, 10.
It's 5 on top and 5 on bottom, so it's got to be 5.
Oh, okay.
Okay? In other words, the top diameter is 54, and the small diameter is 44,
Okay.
so it's got to be 5 here and 5 there.
Okay.
Okay? All right. Let's see. I think I can blow this up a little bit to see it. Yeah, I can just barely make out the numbers now. Okay. A rectangular pen is made with 100 meters of fencing on 3 sides.
Mm-hmm.
Okay. Fourth side is a stone wall. Find the greatest possible area of such an enclosure.
Okay.
Okay. So start off any word problem by doing what?
Finding what you're solving for.
Yes. Picking your variables and defining them.
Okay.
So let's pick some variables. And what do they mean?
Okay. So the area is a variable?
Well, let's start with the width of the rectangle, or the length rather, and the width. So we're going to let x equal the length and y equal the width. Okay, so this is y over here also. Now, the area function is what?
X times y.
Okay, so that's the function we want to maximize. Well, at this point, we can't do it. We don't have any information, but if we consider the perimeter is 100 meters, and according to our variables, what is the perimeter equal to?
2y plus x.
Now, we're going to take this equation and solve for either variable that we want, and then substitute it into the area function so that we'll end up with a quadratic, and then we'll be able to find the vertex of that quadratic and know where the maximum is going to be.
Okay.
So let's solve for,
X?
yeah, it's the easiest. Why not? So x is equal to 100 minus 2y. So now my area function is, instead of x, multiply that out. What do we get?
2y squared minus 100y.
Minus 2y squared plus 100y.
Oh.
In other words, the 100 multiplies the y to give you plus 100, and the minus 2y times the y gives you minus 2y squared. And I reversed the order so we write it in typical quadratic form.
Yeah.
Okay? So now where does the maximum of that occur? Now, hold on just one moment. I've solved and made the area equal y. Don't confuse this with a typical y equals x squared. This is not the same y. In other words, we could have solved for y, and then we would have this thing as a quadratic in x. The fact that it's a quadratic in y does not matter. You can have a quadratic in any variable you want. Typically, you don't use y because y is used as the vertical axis so frequently. But just so you're not confused, this would be solving the same thing as if I had x here. Okay, so where's the vertex?
Vertex of what?
Of this quadratic.
0, 0?
Well, the vertex is minus b over 2a.
Oh.
What is a in our case?
A is 2, negative 2.
Negative 2, and b is?
100. Or
Okay, so minus 100 over 2 times minus 2 minus 4. So,
25.
yeah, that is the y coordinate of the vertex. Oh boy, I made a mistake. We should have solved for y just so we would avoid this confusion. But that is the horizontal component. In other words, the variable we're in. So that is, our answer is 25, 25, and x would be 50. And there's your 100 feet of perimeter. And that gives you the maximum area of 1250.
Oh, okay.
Okay? And what we did, when we solved for a y of 25, that is the maximum area, because the maximum area comes at the vertex. So we know that when the horizontal axis is 25, that's going to give you the maximum area.
Okay.
Okay. You know what? Just for sake of clarity here, let me go back and let's solve this for y. So y is going to be 100 minus x over 2. And now we'll go into our area function and we'll substitute for y instead of x. So it'll be x times 100 minus x over 2. So our area function is now 50x minus 1/2 x squared. So this is a more typical looking quadratic to you, right? Okay, so if we solve for the value of the vertex in this, well, it's minus 50, that's the minus b, over 2a, so it becomes 1, or negative 1, and the vertex is plus 50, so the x value is 50, which is exactly what we got. We got an x value of 50, it's just we solved for the y variable first.
Okay.
Okay?
Yeah.
All right, let me see if I can read this. Apparently try to hit him in the head again. Okay, so this time you toss a rock into the air at an initial speed of 32 feet per second from an initial height of 256 feet, the top of a cliff. As the seagull flies below at an altitude of 128 feet. So we're actually throwing the rock down.
Okay.
Hold on. You toss a rock into the air from a 256 cliff as the seagull flies below. Okay, so I guess you do throw the rock up. Okay? So what is the general formula for the vertical height of projectile motion?
Y or f of x is equal to negative 16 x squared minus velocity times.
It's plus the initial velocity times x plus the initial height. And usually this is a function of t, especially when our speed is 32 feet per second. So let's change our variable to t.
Okay.
Makes more sense. Everything's measured in terms of time.
And don't you use another equation for
horizontal? The horizontal is a different equation altogether. And the reason is that horizontal distance that it travels is only a function of the amount of time it's in the air. It's not being acted on by gravity. The vertical motion is being acted on by gravity, and that's where this minus 16 t squared comes from. This is the fundamental constant, the gravitational force that figures into that.
Okay.
So the equation of our rock, its height at any point in time is going to be minus 16 t squared plus this initial velocity of 32, unless I'm misreading the problem and they're throwing the rock downwards. You first read this with a negative sign in front of it. That's the only reason I'm thinking that might be the case.
I just read it with a negative sign because that was how it was written in our notebook.
Aha! That would indicate to me that the rock is thrown downwards. And of course, if you're trying to hit the gull, you'd want to throw it downward, right? It wouldn't make much sense to throw it up. So this velocity is actually a negative 32 feet per second. And that's why it's the minus sign. The general equation of projectile motion is this, because normally the velocity is in an upward motion. You know, like if you kick a football or hit a golf ball or hit a baseball, you're always hitting it up. This is a strange problem in the fact that you're trying to hit something down below. But that's okay. It's still going to follow projectile motion.
I think that, like, because we worked on these problems in class before, we've never really done it where they're throwing down.
Yeah, I've never seen one done where it's thrown down, to be honest. But you know what? It'll work.
I think he throws the rock up and it comes down.
Well, that always happens with projectile motion. And that would give you a positive velocity. So it would be plus 32 times t. If your notes say that it's minus 32 times t, then that tells me that you're throwing down. Now this problem references a previous problem, right?
Yeah.
Okay. Do you remember what the previous problem? Were you trying to hit a seagull and throwing down, or throwing?
Yeah, it says you stand atop a 260-foot cliff and throw a rock up into the air at a vertical speed of 64 feet per second.
It says you throw a rock into the air.
Yeah.
Oh, the first problem said up into the air.
Yeah.
Okay. Then it is positive 32 feet.
Okay.
But notice what has to happen. You're standing on a cliff that's 256 feet high. The seagull's down here at 128 feet high. You're going to throw this rock and try to do that, right?
Yeah.
Okay. As long as that's our diagram instead of like that.
Yeah.
Okay. I mean, if we were actually on a cliff and trying to hit a seagull, we'd throw it right at it, I think. Maybe a little bit higher, expecting it to drop. But I don't think anybody would throw it up in the air. But that's what this problem is, apparently. It's throwing it up into the air. That means the velocity is positive. Okay? Now, this is the equation of the height of the rock at any point in time, and let's test it. What happens right before the rock leaves your hand at time 0? What is its height?
256.
Yeah, and if I plug in 0 for t, that's what I get. Okay? So the question we're trying to answer is, when is this rock going to be at a height of 128, right? Well, actually, excuse me. What is the maximum height the rock reaches? Let's figure that out first. How do we do that? Remember, when they're talking maximums and you're looking at quadratics, you're talking vertex.
Okay.
We need to solve for the vertex, and we need to solve for what the vertex, in other words, what's the formula for vertex again?
Negative b over 2a.
That's actually the formula for just the horizontal component. So that would be the t value. But once we get that, then we're going to plug it in to figure out what h of t is, and that would be the maximum height. So what is it here? It's minus 32 over 2 times minus that. That's minus 32. So the vertex comes when t is equal to 1. 1 second. 1 second after you throw this rock, it hits its peak and starts falling. What happened to my picture of my diagram? I erased it. Okay. So what is that maximum height going to be? How do we get it?
Plug 1 in as t.
Yeah. So we're going to do h of 1, and that's minus 16 plus 32 plus 256, which is 272. So the rock doesn't go very much high over the cliff, but it goes an extra 16 feet up before it hits its peak and starts coming down. So the maximum height is 272. After how many seconds does the rock hit the seagull? Well, go back to our original equation, and we want to know when the rock is going to be at a height of 128, right?
Yeah.
And that's kind of dreaming that it's actually going to hit the seagull. The proper question is when is the rock at the same height as the seagull? Because it can certainly be at the same height and not hit it. You know what I'm saying? In other words, only in two-dimensional math would it automatically hit the seagull when it was at the same height. But we can certainly solve for when the rock hits a height of 128. We're going to solve this quadratic. For t. Okay, so how do we solve that for t?
Take out a greatest common factor of
what's the first thing you really want to do when you have something that looks like it's in a regular quadratic form and you're trying to solve it?
Oh, subtract 128.
Yeah, in other words, get 0 on one side. So 0 equals minus 16t squared plus 32t plus 128. Now factor out. It'll make it easier to solve. What is the greatest common factor here?
Negative 16.
Does that divide into 128 evenly?
Yes.
Yeah, it does, 8 times. So we're going to divide everything by negative 16. Left side stays 0. This becomes 2t. And this becomes minus, what was it again?
8.
8. Now factor that. Remember that second step is to do what?
It'd be x minus 4 and x, or t plus 2 and t plus minus 4.
The second step is to determine the signs. And this negative sign says that the signs are opposite. So I think it's always worth doing that second step rather than trying to solve step 2 and 3 all at once. It's okay to do it on an easy one like this, but if you get harder ones, then you'll want to do it step by step. Okay? And you're right, it's t plus 2, t minus 4, which gives you two different solutions for t. What are they?
4.
That's one of them.
And negative 2.
Right. Now, time doesn't run backwards, so any time you're solving for time and you get a negative solution, it's considered an extraneous one. We cross it out, and our answer is 4 seconds after the rock is thrown. The rock is at the same height as that seagull. Presumably, it'll hit it on the head. Suppose the rock misses the seagull. After how many seconds does it hit the unsuspecting duck that is floating on the surface of the sea? So now, when we go back to our original equation, what are we going to substitute for h? In other words, this time we substituted 128 for h.
Oh.
Right?
Mm-hmm.
Hold on one second here. Ellen, I am very sorry. I totally lost track of time. I am 9 minutes.
Yeah.
I am 9 minutes late to my 4:30 appointment. So I'm going to have to run. But just to finish this problem, make h of t 0 because that's the altitude that the duck is at.
Okay.
And then go back and solve that quadratic when that quadratic is equal to 0. So instead of this, it'll be 16 here. And then factor that and solve that.
Okay, thank you.
All right, Ellen. Thank you. Talk to you next time.
Bye, thank you.
Bye-bye.